we're going to look at just isotopes. So we're not focused on them being ions, just an isotope. And remember, an isotope is atoms of the same element that have different numbers of neutrons. And so what I've done for you is I've written out some important notes up at the top of the chart, within the chart, and then all along the side of the chart. What I've done is I've taken and written out the isotope notation for each one of the isotopes listed. So the chart has it filled out like this, where you have your Z number, your name of your element. So I'm going to put X, even though I know that represents symbol. We're just going to pretend it's the name. And then the A number, which is the mass number. So that's how they've listed it. We're not going to follow that method in class. We're going to stick to the method that I have right over here for you, which is the element symbol. On top, the A number, which is the number of protons plus neutrons. On bottom, the Z number, which is the number of protons. So it's always top heavy. Big number goes on top. Small number goes on bottom. And so you want to have a periodic table out in front of you. But for this particular chart, because of how they've provided you the setup, they've already given you the atomic number. And so you don't really need a periodic table for this chart specifically. So my atomic number for uranium, I know it's 92 because they've told me that it's 92. And just where I wrote it out to the side, it's 92. You can double check with your periodic table. So I'm going to fill out 92. If I know the Z number, which is the atomic number, I automatically know the number of protons. Number of protons as the defining characteristic of the element. It will never change. It's not going to be 91 protons. It's not going to be 93 protons. I'm not going to gain or lose a proton because that makes me a completely different atom, a completely different element. And so my mass number in this case is 235. And so in my notation, it's the one on top. So I'm going to go ahead and fill that out. It's 235. For isotopes, I really want to focus on understanding how many neutrons they have. So I have two options. I can just do A minus Z if I'm given that information. Or if I really need it, I can map it out where I know that my A number is protons plus neutrons, and I'm going to subtract my protons. That's going to really be the only way you can determine number of neutrons. You need to have the mass number available. Number of protons you can always get from the periodic table. So that doesn't have to directly be given to you with the question. And so for my number of neutrons, I'm going to say 235 minus 92 because that is my mass number and that is my Z number. And so when I calculate 235 minus 92, I get 143. How many electrons do I have? Well, this is not an ion. It is still a neutral atom. And so how many protons I have has to be equally balanced to how many electrons I have. So that's going to be 92 as well. If I now look at my other isotope of uranium, then now I have a mass number of 238. And so my atomic number, my Z number, hasn't changed. It's still 92. My mass number this time, though, is a little bit different. It's 238. My number of protons, that's not changing. I'm still dealing with uranium. It's still 92 protons. My number of electrons is still 92 because this is not an ion. It's just an isotope. The number of protons and electrons are equally balanced. But my number of neutrons is what makes this different. It's what makes it an isotope. And so this time around, my mass number is 238, but my Z number, my atomic number, is still 92. So 238 minus 92, this isotope has 146. So notice here that your number of protons is the same because you're the same element, but your number of neutrons is what makes you different. That's what makes you an isotope. So let's look now at boron. Boron will always have 5 protons. But as isotopes, two common isotopes of boron is boron 10 and boron 11. And so if I'm boron, my atomic number is always 5. That means I always have 5 protons. These are not ions. They don't carry a charge. So their pluses have to balance their minuses. My mass number was given to me in the problem. So here I was told it's a mass number of 10, and here I was told it's a mass number of 11. My number of neutrons are going to be different, where I'm going to say 10 minus 5 and 11 minus 6. So 10 minus 5 is clearly 5. 11 minus 6, still 5. So notice what's happened here. I'm sorry, guys. Why did I say 11 minus 6? It's still 11 minus 5. That didn't make any sense. So I don't even know where I got the 6 from. It's still 11 minus 5 because I want to do number of protons plus neutrons, which is the 11, and 5 number of protons. So 11 minus 5 is still 6, because you should never have two isotopes that are different but the same number of neutrons. That's not an isotope. So again, my number of protons is the same, but my number of neutrons is what makes me different. Those are the two different isotopes of boron.